All right, recording is rolling. We're in the last few minutes of class, so I want to go over the ideal solutions to these one by one. So maximum versus equilibrium stretch length. What does your graph shape look like for this one? Yeah, should ideally be linear. Hey, guys, don't just blind copy this. Really, what you do is what I want you guys to do is like scale each axis, post like 0, 1, 2, 3, or whatever your units are for okay. So you should have individual points. Maybe your points like something kind of like this, for example. I'm just kind of make something up, right? But it should roughly linearize. And what's the slope of this line? Yeah, 2. It's like 2 to 1. That is consistent with what we did yesterday, right? Like 2 times. Okay. The maximum stretch should be twice the equilibrium stretch. Okay. What about weight versus equilibrium stretch? Also linear. And what is the slope of this line? Yeah, k. Right. Oh, so if I'm writing equations, this would be x max should be 2 times x equilibrium. This should be the weight is equal to k times x equilibrium. Okay. How about 2 pi quantity squared m versus time period squared? What's that? Yeah, also linear. It's one way to linearize it, right? Yeah, don't just blind copy a straight line, but draw individual dots, and ideally it should be like that. Okay. And what is the slope of this line? Yeah, k, spring constant. Okay. So this is 2 pi quantity squared m is equal to k times time period squared. Right? Not the only way to linearize it, but this will, the nice way of doing it this particular way is that the slope happens to be exactly the spring constant. So once you find the slope of that graph, you have the answer to the question, what is the spring constant? Okay, there you go. And AP, you guys should ideally be able to get that from scratch. It comes from the originally the equation time period is 2 pi times the square root of m over k. Right, that's straight off your AP equations. You should be able to take that and rearrange it so that you could linearize a graph like that. Okay. And finally, displacement versus time. No, this is lowercase t time. This is not time period, but this is just time. Okay. What does that graph look like? It could be a sine or a cosine. You could do sine or cosine. Right? I'm going to do cosine. Say like if you started counting the time when it was starting from some displacement, right? So you pulled it, stretched it, maybe let it go, and then it went to like this type motion, oscillatory type motion. Okay. Now there's different properties of this that should align with some of these other graphs. Okay. Like, for example, if you go from crest to crest, because I mean sine or cosine wave, you got crest to crest. Okay. And since we're talking about something to do with time, that represents one what? One time period. Yeah, one time period. Okay. I might call it like T1, or call it like T1 right there, right? Okay. And what about this distance right here? What is from this nodal line to the crest? What is that? Is the amplitude, right? And then what else we got in here? Right. How about x max? Could probably be, and depending on how you set it up, x max is probably like twice the amplitude, right? I'll say x max equals 2a, right? Like if you dropped it and blah, blah, something, right? That might be the case. Right? And what could an equation for this be? Maybe x equals amplitude times, do a cosine. You got 2 pi times the regular frequency, right? Which is the same thing as 2 pi over time period, right? Times the time is a variable, right? So that could be the equation of that graph. Okay. Right, there you go. Right. So that's the ideal solutions, right? Right. So if you have finished those all before the end of class, then you can turn that into the grade tray. Again, I'm looking for, I want you guys to plot all your individual points, scale your axes, label your axes, put units, right? Like seconds, for example, this could be time in seconds, right? This could be x in like meters or centimeters, right? And then if you have that all finished, then turn that into the grade tray. If you haven't quite finished the graphs, then you can turn those in tomorrow.